Electromagnetic waves are defined as waves that have oscillating, perpendicular electrical and magnetic fields that are perpendicular to the velocity or the direction it's traveling. Here, I tried to draw it, but picture that this blue magnetic field is actually perpendicular to the red electrical field. Now these waves travel at the speed of light in a vacuum, and there's a relationship between the velocity, their frequency, and their wavelength according to this equation. Note that the wavelength corresponds to the distance between one peak and the next peak, or one trough and the next trough, and that the frequency is just the number of waves that pass by a given point in a second, which we refer to as hertz. Now because wavelength and frequency can vary for light, and c is a constant, we actually see a spectrum of electromagnetic waves. Here, low frequency waves have high wavelength, and this corresponds to radio waves, microwaves, and infrared waves. On the opposite end of the spectrum, high frequency waves are really high energy waves, have low wavelength, and they correspond to UV, X-ray, and gamma. So that's why these waves are particularly dangerous in the world, and these waves are not as dangerous. Now in between, we actually get the light that we can see. This is referred to as the visible light spectrum. Now you may have heard of Roy G. Biv. Roy G. Biv actually tells us the colors that are in the visible light spectrum from low frequency to high frequency. We have red, orange, yellow, green, blue, indigo, violet. Red, because it has low frequency and higher wavelength, corresponds to 750 nanometers. Violet is a little bit higher energy, a little bit higher frequency, and lower wavelength, and it corresponds to 400 nanometers. We can characterize any wavelength or frequency as long as we know the speed of the object, which is usually c.